Hello, I have a bowl of water on a scale which says 0 grams and a hammer, and the question is, what will the scale say as I slowly descend my hammer into the water without touching the ground? Will it A, still say 0 grams, or B, say something more than 0 grams, or C, say something less than 0 grams? I'll give you 5 seconds to think about it. Okay, so let's see what the answer is. So we can see the scale is clearly showing 0 grams, and as we slowly dip the hammer into the water, what comes out is something which is definitely more than 0. And just to be clear, I'm not touching the ground. And intuitively this also makes sense. So as you might know from your experience, it's easier lifting up a person, for example, in the water than on land. Because in the water there's the buoyancy force which helps you lift up the mass. And even though the mass hasn't changed, some part of the mass is lifted by the water, by the buoyancy force. And this exact part is the part which is shown by the scale. This is the part of the mass which you yourself don't have to lift anymore, because the water is helping you, the buoyancy force is helping you. To understand this mathematically, let's imagine we have a solid in a liquid with densities PS and PL, solid and liquid. The gravitational force now acting on the solid is mass times gravity constant, so density times volume times gravity constant. We now know that the effective force on the solid depends on the difference of density, so if there's no difference in densities, there will be no upward or downward force. So the effective force is difference in densities, so density of solid minus density of liquid times volume times gravitational constant. So we can now see that this extra part acting against gravity, and this extra part is called the buoyancy force, which points upwards. So the buoyancy force is equal to the density of the liquid times the volume of the solid times gravity constant, so 9.81 meters per second squared. And now to understand which of all these forces acts on the scale, we first have to understand Newton's third law, which says that for every force there's an equal but opposite force. So for example, if you're sitting on a chair and trying to pull someone else to you with a rope, then not only you are pulling the person to you, but also this equal but opposite force is pulling you towards the other person. This is Newton's third law. So the total force which acts on the solid is the gravitational force, which points downwards. And there are two forces pointing upwards. The first one is the buoyancy force, and the second one is the force exerted by my hand, which is pulling the solid upwards, so it doesn't fall down. And now to each force there's an equal but opposite force. So the opposite force to my hand pulling up is the solid pulling my hand down. And the opposite force to the buoyancy force is the force acting on the scale, which is the reason why the scale is not showing 0 grams anymore. And as we know, the buoyancy force is density of liquid times volume of solid times gravity constant. So this is the force exerted on the scale. This is the reason the scale is not showing 0 grams. And just to prove you this makes sense, maybe assume the bowl is not filled with water but with air. In this case, the density of air is almost 0 approximately, which means there will be almost no buoyancy force, which makes sense. Like if you descend a hammer into a bowl of air, then the number on the scale almost won't change, which is exactly what this formula tells us. Okay, that was it for this time. If you have any questions or recommendations, put them in the comments, and if you have been, thanks for watching.